Today we are studying the 6.4 new topic, general exponential and logarithmic function. In the last sessions, we have studied the exponential function and the natural logarithmic function, right? And we have seen that from this, we have seen that the natural logarithm and the exponential functions are the inverses of each other. Here we are going to study a new topic, that is the exponential function with a base a. Exponential function with a base a. For that we have to recall something from the last class. So this is equal to, we have to remember some results of exponential function with base e. This is the exponential function f of x equal to e raised to x with base e. This is the exponential function we have studied in the last class, right? Next up, we have to remember one or two results for this definition of exponential function with a base a. So e raised to log x is equal to x for x greater than 0, and also e raised to p raised to r equal to e raised to p r. So p is real number and r is rational number. So what will be a raised to r, where a is any positive real number? Suppose a is any positive real number, positive real, then a raised to r will be is equal to, I can write this as e raised to log x equal to, I can write this as e raised to log natural log x equal to x here. So I can write this as e raised to log natural log a raised to r. This is equal to e raised to r natural log a. Also I can write as e raised to log a raised to r. Right? This is we have to remember. So I am going to define the exponential function with a base a. Function with base a. Let a be a positive real number. Let a be positive real number. And a not equal to 1. A not equal to 1. A not equal to 1. The exponential function with base a is a function defined by f of x equal to a raised to x, which is equal to e raised to x log a. Is equal to e raised to x log a. For every real number x. For every real number x. The definition is that a being a positive real number and a is not equal to 1. The exponential function with a base a is defined by, this is equal to a raised to x, and also this is equal to e raised to x log a, natural log a. This is the relation between this natural log and exponential with the exponential function and the exponential function with a base. This is the definition, right? So we have to remember that equal to the exponential function is equal to a raised to x, which is equal to a raised to x log a. But a not equal to, we need this to calculate, some. So first problem is equal to evaluate the expression, to evaluate the expression accurate to 5 decimal places. 5 decimal places. First one is 3 raised to root 2. Second is 2 raised to 5. The solution is, we can calculate this as, this is 3 raised to root 2. This is of the form a raised to x. We can calculate this by, this is equal to, we know this is a raised to x log a. So I can write this as, in the place of x, this is root 2, the place of a here, 3. So this is equal to, e raised to root 2 natural log 3. So this is approximately 4.72880. From the calculator, you have to calculate that. The next one is 2 raised to pi. 2 raised to pi, similarly, I can write this as e raised to pi log 2. It's equal to approximately 8.82498. 498. Next, some more theorems. Theorem 1. Laws of exponents. Laws of exponents. First, let A and B. Let A and B be positive numbers if x and y are real numbers. X and y are real numbers. Then first one is a raised to x into a raised to y equal to a raised to x plus y. Second one, a raised to x raised to y equal to a raised to x into y. And the third one is ab whole raised to x equal to a raised to x, b raised to x. And next, a raised to x by a raised to y is equal to a raised to x minus 5. Next one, a by b whole raised to x is equal to a raised to x divided by b raised to x. We have to prove these results. So in order to prove this, first to prove we will do, and next we have to do this. So first one, how to prove this. How to prove the first one. First one is A, the proof for A. First one, that is A. A raised to x into a raised to y. This a raised to x into a raised to y is equal to, the place of a raised to x, we can write this as e raised to x log a, natural log a into e raised to x, natural log x, to e raised to y, natural log y. So by the definition of the exponential function, right, some results of exponential function is equal to e raised to x log a plus y log a. This is equal to e raised to x plus y into log a. This is same as a raised to x plus y. Similarly, how can you say this a raised to x into y is equal to b a raised to x into y? I can write this as a raised to x can be written as e raised to x log a whole raised to y. This is equal to e raised to x y log a. By the definition, by the results in the exponential function, which is equal to a raised to x into y. Similarly, you do the proofs of all these up to e. Right? Next is, what will be the derivative of a raised to x, and the chain rule. Using the chain rule, how to calculate a raised to u if u is a function of x. The derivative of a raised to x. Derivative of a raised to x and a raised to u. This is the theorem 2. Theorem 2. So let a be positive number with a not equal to 1 and let u be differentiable function of x. Then first one is d by dx of a raised to x equal to a raised to x natural log a. And the second one is d by dx of a raised to u equal to natural log a into a raised to u into du by dx. How can you prove this? Using the definition itself, we can prove this directly. So first one is proof. D by dx of a raised to x, that's equal to d by dx of e raised to x log a, which is same as e raised to x log a into d by dx of x log a. The derivative of x log a is same as derivative of x. This is constant. So this is derivative of x log a is log a. So this is log a into e raised to x log a, which is same as log a into a raised to x. This is the result. Next one is we have to do derivative d by dx of a raised to u is equal to what was that? A raised to u equal to log a into a raised to u into du by dx. This is d by dx of a raised to u, which is same as d by dx of e raised to u log a. This is a function of e raised to u log a is a function of u is a function of x. So this is e raised to u into log a into du derivative of d by dx of u log a, which is equal to e raised to u into log a into this is du by dx into log a. Log a is constant, so this is equal to log a into e raised to u log a into du by dx, which is same as log a into a raised to u into du by dx. Right? This is the proof of the second theorem. In the next video, I like to show some examples to find the derivative of this a raised to x, and like this, using the chain rule, we have to find out some more examples.